Okay, so I'm going to go through how to do some Ohm's law practice problems. You should have read the material on Ohm's law at this point. Okay, and Ohm's law, if you looked at the notes, and it's also in your formula chart, it's written I equals V divided by R. Okay, and I'll write up here, but I is current, and it's measured in amps. And the abbreviation is A. V is voltage, and it's measured in volts, and it's abbreviated V. And last but not least, R is resistance, and that's measured in ohms. And the abbreviation for that is omega, the Greek letter omega. Okay. Okay. So Ohm's law is written like this. And this is in your formula chart. Okay. I equals V over R. So the current that goes through a circuit is the voltage of that circuit divided by the resistance of that circuit. Okay. So the current increases if the voltage increases and the resistance stays the same. And the current also increases if the resistance decreases. All right. Okay, so here's the problem. A resistance of 30 ohms, so this is R, is placed across a 90-volt battery. Okay, that means your voltage is 90 volts. Well, this is also called your potential difference. The battery creates that. Okay, so what current flows in this circuit? So I equals V over R. Well, V is equal to 90 volts divided by 30 ohms. So the current is 3 amps. It's pretty easy, right? Okay. Okay, so there's another way to write this, and I'll bring it up right now. Sometimes I like to write, I'll go down and I'll do a different one at this point, okay? There's number 4. Let's talk about that for a minute. You should do the remaining problems, all right? So you have a motor with an operating resistance of 30 ohms, and it's connected to a voltage source. There are 4 amps, so this is the current. You have the current flow in the circuit. What is the voltage of the source? Well, there's another way to write this equation, and I'll show you. Okay, if you go back up here, it's V over R. Okay, there's another way to write it. V equals I times R. So what's the voltage of the source? Well, it's equal to the current, 4 amps, times the resistance, 30 ohms. Okay, and in this case, it would be equal to 120 volts. Okay, now you do the remaining problems. They're really straightforward. They're not complicated. Now I'm going to talk a little bit about the next page a little bit, and I'll give you an example. So this is just a table, and the table shows Ohm's law, V equals IR. Okay, it also shows the equation for power. Power is equal to the voltage times the current. Okay, so this first one's kind of solved for you a little bit, but basically I'll do it and kind of show you. But V equals IR, so we want to find that. So V voltage equals IR. Well, let's just take a look at that. IR is 10 times 5. It's equal to 50 volts. Okay, and you notice that's the number here, right? The power, okay, is equal to And power, the units for power, let's talk about that for a second. Power, the units for power, this is power. And the units for that are watts. And watts are abbreviated W. Okay, so this is V times I. Well, V is equal to 50 volts times the current, which is 10 amps. So the power here then, P, is equal to 500 watts. All right, it's a lot. That's big, right? Let's do one more. Let's do the second one. Okay, I've got amps and I've got ohms, and I need to find the voltage. Okay, so the voltage is equal to IR. So that's 10 times 8. And that's going to be equal to 80 volts. Okay, then the power is equal to 80 volts times the current, which is 10 amps. So the power then is equal to 800 watts. Okay, so the rest of these problems, take a look at them and take care of these. Do these on your own. Follow my example. You can do the rest of these Ohm's law problems, and then also do these Ohm's law and power problems. All right. Okay, get started on those.